Hey, welcome back. In this lecture, we're going to talk about threads and how they relate to asynchronous programming. So, what is a thread? You can think of it like a worker. The worker handles tasks one at a time. Imagine a post office where the clerk handles customers. The customers stand in line and the clerk helps them one by one. Same with a thread. It picks a task, it does it, it finishes, and only then it moves to the next. Now, in code, thread runs functions. Each function is a task, and just like our clerk, a thread can only run one function at a time. Once a function starts, it always runs to the end. You can't pause it or interrupt it midway. Only when the function finishes does the thread become available again. Now, the tasks wait in a queue. So whenever the thread runs a function, as soon as it finishes, it moves on to the next function in a queue. But how do these tasks get into the queue? Well, there's only a few special APIs that can add them. One example is setTimeout. setTimeout takes a function and a time as parameters. After the time passes, the function is pushed into the queue. But the key is, it doesn't block the thread. It just sets a timer and returns right away. So the setTimeout function ends in 0 time. setInterval works similarly. It keeps pushing the same function into the queue over and over again after each time interval. Now, event handlers work the same way. When you click a button, the click handler is added to the queue. That way, it runs only when the thread is ready. Another example is XML HTTP request. It sends a request to the server and it takes a callback. When the server replies, the callback is pushed to the queue. Now, there's a few other APIs like this, but actually not that many. So, if JavaScript can only run one function at a time, how is asynchronous code even possible? To understand that, we need to separate two different ideas: asynchronous programming and concurrent programming. Concurrency means running multiple things at the same time. That needs multiple threads, so that's not possible in JavaScript. Asynchrony is different. It's about freeing up the thread so it can stay available. That way, while you're waiting for something to finish, the thread can keep going, doing other work. So let's look at a simple Angular example. In this example, we have a simple app component. As we can see, it only contains 2 buttons. Now, the components constructor, we use the setInterval API so that we log tick to the console every 3 seconds. This will help me demonstrate the way asynchronous programming works. The first button calls the callAlert function. This function uses alert, an old API that shows a pop-up, but it has a special behavior. Notice what happens. I will clean the console now and call the function. Now you can see that an alert pops up. Now while it's open, nothing else runs. You see that the function hasn't ended, so the thread is stuck. Now, what's important to understand here is that even though setInterval is still trying to add tick messages to the queue, the thread isn't free to run them, so the screen freezes. The alert function does not end until the user clicks OK. And while the user doesn't do it, the function is idle. Now, while the thread doesn't do anything, it is still busy because the function captures the thread or blocks the thread. This is what blocking code is. Now, when we click OK, you can see that the message in line 20 appears. So that means that the alert function has actually completed running, and the tick message that was waiting in the queue immediately executed, and now you can see it here. Now let's talk about the second function, run timeout. So this function uses the setTimeout API. This one sets a timer for 10 seconds and logs a message right after calling it. Now, since setTimeout doesn't block, both log messages show up right away. Then, 10 seconds later, the second message appears, and that happens when 10 seconds are over. This is what asynchronous programming is about. Keeping the thread available. To make this work, your function needs to be short. Ideally, they should end instantly. That way, the thread is always ready to grab the next task. So let's summarize these two patterns. In synchronous code or blocking code, the alert example, the function starts, opens a pop-up, then waits. The thread is captured until the function ends. Now, in today's JavaScript, in modern JavaScript programming, this is discouraged. The second pattern, the asynchronous code, here we use two short functions, one to start the action and one as a callback. The action registers the callback to run later, and the thread stays free in between. So asynchronous programming means using callbacks to let the thread stay open and responsive. But why is it important? It's important because some tasks in the queue are critical. They refresh the UI, or they handle user input, or handle events. If the thread is blocked, then the app looks frozen. With asynchronous code, those important tasks can run, and the app stays smooth and responsive. That's why in this series, we'll write only asynchronous code. We'll use functions that finish quickly so that the app never freezes. Now, writing asynchronous code involves callbacks, and that's not always fun. It gets messy, and that's why promises are required. That's where promises come in. In the rest of this series, I'll show you how promises help to write asynchronous code that feels clean and easy to follow, almost like writing regular synchronous code. And that's what we're going to do in the next videos.